Good morning. So today what we're going to do is take a look at creating a very simple rocket thrust using N particles and Redshift. So we're going to render these off in Redshift. So first thing I'm going to start off with is just a very simple animation. So we just have this kind of cylinder shooting off into space. Okay, so to test particles, ideally, having something animating is always a good place to start, because it is going to be based off of what's happening in the scene, because it's all calculated frame by frame, and it is dynamic, so there is a little bit of testing that needs to be done. So because it is particles, it's a simulation in Maya, it's very important that we do switch our timeline at the bottom to go from real time or whatever these settings are. Typically I like switching it over to this guy right here, play every frame maximum real time, because it does need to calculate frame by frame consecutively, and if it doesn't, and if it skips frames, then it might explode or it might not give you an accurate simulation. So I'm going to click on that. Next thing is I'm going to create something to emit the particles from. You could just use a regular emitter, which is just kind of like a little, it looks like a light. It's like a little point that particles emit from. But I think I'm going to emit from a surface. So I've already just extracted some faces here. You could use a disk. It doesn't really matter. But I've got this shape right here, if I were to isolate it, which is just a disk essentially. And I'm just going to emit from this. It could be any shape, but in this case I just took the cylinder and I extracted those faces. I basically just duplicated those faces, which is this icon right here. But again, you could just create just a regular old disk if you wanted to. And what I'm going to do is I'm going to take that disk and I'm going to parent it to the rocket. So essentially when this moves up, that's going to move with it. Right, so that's just going to go along for the ride. All right, next thing we're going to do is, maybe I should save this, save scene as, and let me just go into scenes and I'll call it particle start. All right, so we're going to add in our particles next. So we're going to be using the effects menu, and specifically the N particles, or that's how we're at least going to start. So I'm going to tear off this menu. So we're going to, as I mentioned, emit from that shape. So with that disk selected, I'm going to go down to, where are we here? So I want to create an emitter, and I want to emit from object. And I'll just go to the option box here. And you can switch all this stuff afterwards. Rate, we'll keep that low for now. I'm going to switch that from Omni to Surface. And again, we could do this after the fact, but might as well do it here. And before clicking OK, actually, let me just go close. We also want to choose the type of particles. So the create options, we're just going to create points. You'd think you'd want to use maybe clouds or something like that, but unfortunately these are all software rendered solutions. For Redshift, points are fine. Essentially it renders little spheres anyway, no matter which option you choose, but I just find going with the point just simplifies things. So again, going back to emit from object, I'm going to go to a surface emitter and apply. Close. So it looks like the disk disappeared, but it's still there. Basically, we now have a particle shape. And if I were to push play, we would get something that looks like this. Right? So it's just kind of this little kind of trail of falling particles. Right. So we're going to be creating a smoke trail. So, sure, gravity might pull down on them, but with the heat and whatnot from the thrust, you would imagine that, as hot air rises, they wouldn't necessarily fall down quite so drastically. So the next thing I want to do is I want to go into that particle shape. So I'm going to go into the particle shape here. And there's this section called dynamic properties. So I'm just going to open that up. And we have these two values here. We have dynamic weight and conserve. So if I were to go in and turn down dynamic weight, and we can just see what happens here, you can see that they just kind of stick in place, because essentially external forces like gravity start to have less and less effect on the particles. Now you can still see they're kind of moving and drifting around a little bit. Basically they're kind of just slowly going off in the direction they were created in, but you know, they're not really falling down with gravity. So, you know, we could play around with this and give it a you know, a degree or a certain degree of gravity, but we don't need to give it like a ton. So the other thing that we might want to consider doing is bringing in a conserve value. So if I were to zero the conserve, basically as soon as these things were created, they're just going to more or less kind of stop where they are. So if you were to turn both of these off, basically these would be just kind of frozen in time, essentially. So conserve is dealing with how fast the particles are losing energy. So, you know, something a bit more real world would be like 0.995 or something like that. So there'd be kind of a slight energy loss. But again, for this, I want them to kind of hover around and be a little bit more under the control of the turbulence fields we're going to create, which will kind of create that kind of wispy effect. So I'm just going to kind of go with a mid value for that. And I'm going to start by going with a bit more of a mid value for this one as well. So like 0.5. All right, so something about like that. So the next thing I want to do is start getting the wisp pattern. I'm not worried about thickness and whatnot of the simulation just yet, just because it's going to be a lot faster to kind of iterate over and over again with fewer particles. So I'm going to create a field next that will allow me to create kind of that wispy pattern. So let's see here. So for that, I'm going to go in and select my particles, and I'm going to create a field. And those are located under, again, if we go up to the top here, under fields and solvers. So this first section here has a whole bunch of different fields, but the one I want to use right now is the turbulence field. So I'm just going to click on that. So you can see that, you know, it doesn't really have much of an effect at the moment, right? So what I'm going to do is I'm going to start playing around with these values here, the magnitude, attenuation, and frequency. So if I were to, you know, just kind of go crazy and give this like a super high magnitude, you can see that it's starting to move the particles around, specifically around where this is placed, right? There's a fall off from the center of this. So if I wanted this to be more of a larger fall off, I could either zero this, which is infinite fall off, right? Which would be kind of crazy. Or not, you know, maybe that does work. If I were to lower this down a little bit, maybe that kind of works. Or, you know, I could go in and play around with how much fall off, like what's the range where I want the turbulence to be affecting these particles. So maybe I want this to be a bit higher, like 50 or something like that. Well, if it allows me to go higher than that, there we go, 50, of course it does. Yeah, but it's still not really giving me exactly what I want. Let me just go with a slight lower value. So you know what? Let's go 0. There we go. And I'm just going to kind of play around with this. Now you can see that, you know, we've got a lot of little lispy. I'm feeling very lispy at the moment. A lot of wispy bits going on. So this is dealing with the frequency. So the higher the frequency, the more noise kind of gets added into it. And the lower the frequency, obviously, then it's just going to be a straight line. So I want to keep things together. So I'm going to start by going with a lower frequency value. Oh, there we go. Yeah, something like this. We're having those kind of cool kind of anime style trails. That's kind of where I want to go with this. So let's reduce that magnitude down just a little bit. And I'm going to play around where this is positioned. That's cool. Yeah, so that's kind of what we want, right? We want kind of that spirally spirally trail essentially as this thing goes past camera. So I think that's going to kind of work for us. And then this stuff's going to dissipate and disappear over time. So that's actually looking kind of cool. You know, I could try a slightly higher value to see what I get. And again, that's kind of interesting as well. Just a bit more extreme, and that's cool. Yeah, so maybe I'll just leave it there. And we could also play with like noise levels and stuff like that, just to break things up just a little bit more if we needed to. And don't forget, if you're finding it's too much, we can always go back to that particle dynamic weight value. So remember, the lower the dynamic weight, the less external forces affect the particles, right? So if I were to go a little bit lower, you can see that it's still there, but it's just a little bit less. And maybe I'll just kind of slowly crank that up. So that's looking kind of cool. So something maybe about like that. Cool. All right. So next thing I want to look at are maybe coloration and maybe have things dissipate over time. So if I close this up, we have Perparticle Attributes. Now before I go into the Perparticle Attributes, what we're going to want to do is activate the lifespan. So a lot of these Perparticle Attributes work best if there's a beginning and end, so a life and death of the particle. So it's able to calculate how much things change between those 2 points, essentially. So at the moment, we have live forever on, so they never die. So we couldn't do things like fading things out with opacity or changing color and things like that over time. So we do want to establish a beginning and end. So typically what I'll do is I'll just go with a random range. And when we see a value like that, that just refers to 1 second. So if you're set to 24 frames per second, then this would be 24 frames. So actually, let me reduce this down here to about 40 frames. I think that's around where it leaves frame there. So lifespan 24. So you know, basically this is going to start disappearing at around 1 second. You can kind of see there it goes, right? So the next thing I want to do is I want to randomize that so it doesn't just look like a wall is clipping this as it goes up. So I'm going to put a random range of almost the exact same value, so something like that, and it's going to kind of flicker off like there's little embers lingering around and whatnot. So it's a little bit better. And then I have to think, well, is 1 second too short though? So maybe I'll go a little bit higher, like maybe 1.5 seconds, so that we still have this kind of lingering effect. And that's kind of cool. Next thing I want to do is go in and now add in maybe a color change and opacity. So those can be found under the Perparticle Attributes. So we have these guys right here. And we have a bunch of attributes we can add in here. So for example, I'm probably going to want to add in a wait, these are not the ones I want though. Let's see here. I'm going to pause. Actually, I think these are them, but nope, that's not it. Where did those Perparticle Attributes go? Okay, I'm just going to pause for one quick second. Right. They're not there because I haven't actually created them yet. So basically, we want to have opacity and color. If I go down here to add dynamic attributes, we've got opacity and color here. So I'm just going to add in the Perparticle attribute, and there's opacity. And then we're going to add in color as well. So Perparticle attribute. There we are. So for opacity, what I'm going to do is right click in here, and I'm going to create a ramp. And now if I were to push that, you can see we get this nice fade off. So they don't just kind of flicker off, they kind of fade off now as this kind of goes off, which is pretty nice. And then for color, we have an RGB Perparticle right here. So I can do the same thing. So I can create a ramp, and then I'm going to go in and edit that ramp. And you can do the same for the opacity as well. So you just right click, you get this guy, go edit ramp, and then we can change the color. So this is birth, and this is death. So this is going to be the closest to where the particles are born. So again, you can choose any color you want and transition it to any color you want as well. Right, and they're just going to kind of fade off. That's kind of cool. And you know, for the example that I showed, it was just different shades of blue essentially. But again, you can go with whatever color suits your project. So that's that. And then opacity, if I want it to die out a bit faster, I could change that as well. Another thing we might want to consider doing is particle size. So changing the particle size over time. So what I could do is I could set this to age, right? So that looks at the birth and death of the particles. And then I can look at maybe changing the things like the radius and things like that. Now it doesn't seem to be updating at the moment. So let's see. I think this is more of a rendered thing, right? So if I were to actually go and do a test render, which isn't going to look so good at the moment, but let's check it out. I don't think I have any lights in here. Let me just create a dome light. Oh, that's not good. Okay, well, let's see. It's not able to find my Redshift, so I might have to make this into a two-part video, because I might have to restart my machine. So do I have? Oh, that's unfortunate, because I was just using Redshift 2 seconds ago. All right, well let's go as far as we can. So this is kind of a rendered thing. So I just got to be careful with that size, because at the moment we also have to think about the collisions. So I do have self collisions off at the moment. If I turn that on though, we do get a slightly different effect. So you can see that, you know, the size is directly affecting how those are spread apart. So let me start with them a little bit closer together. So with self collisions on, you know, they'll actually bounce off each other and again create a slightly more realistic result. It might take just a little bit longer to calculate though. But that's actually not too bad. It's not too bad. All right, so next thing I want to do is go into my emitters, and I'm going to start adding in more particles. Now this will affect your self collisions, because you have more particles, then, you know, it might take a little bit longer to calculate. So I'm going to go in and change this to maybe, I'll start with like maybe 5,000. So you can see that, yeah, it's way too way too thick in terms of the numbers here. So I'm going to bring this down just so I get a bit of a better result. All right, so that's looking pretty cool, right? So we get this kind of neat trail effect happening. So that's looking kind of awesome, right? And I think we're ready to just throw on the shader and render it off. I think that's actually pretty good. So if you're finding it's a little bit long to calculate, again, you could turn off self collisions. It'll be a little bit faster on the calculations. It might give you a slightly different result. Now my particles, I probably made them so tiny now that we're not going to see much of a difference, but they are going to scale down over time. So they're going to fade off, but then they're also going to kind of shrink down to nothingness. So it's going to create this interesting effect. Maybe not down to complete nothingness though. So let me bring it down to maybe like that. Cool. Neat. Last thing, since we're in here and I can't do the shading part of it, I do want to create a cache for this. So as particles, as I mentioned, it has to calculate frame by frame consecutively. So that means I can't scrub in my timeline. If I do, you know, the particles won't update and they'll just kind of get more and more messed up. And in fact, I should probably do an increment and save in case it crashes, which particles could crash quite a bit. So I'm going to want to do a cache, which will just lock everything in place. So I can scrub it and do whatever I need to do, which will make it easier when I'm testing out the rendering of this. So to do that, I'm going to go into the N cache menu. I'm going to create a new N cache, so an N object. And basically just want to make sure this is going into your right Maya project. So make sure your projects are set. It goes into a cache folder, and under cache, there it goes there. And we can just call it whatever the cache is for. So rocket trail. I usually like just having one file, to be honest. We'll go with the time slider. So whatever your range is set to, that's the range. So if you want to go longer, then you got to be careful, because then you'll have to recache it again for the extra length. And one last thing, if you did, right now my simulation is starting right at frame 1. If you did want it to start later, let's say your rocket doesn't fire until frame 8, what you could do is just go into your particle right here, and if you just go into the channel box, it's probably the easiest place to find it. Down near the bottom, where is that actually? Here it is here, start frame. It's actually under the nucleus, sorry. I was just thinking old school particles for a second. So if you go into the nucleus, under time attributes, you can change the start frame. So again, you would just kind of change it to whatever number. Let's say my animation starts on frame 10. As soon as I switch that to frame 10, now my particles won't start until it hits frame 10, basically, right? But in this case, it does start right at frame 1, so I'm just going to switch that back to frame 1. Cool. So the next thing I want to do is the cache. So let me go back under that, so which is right here. So the last thing you're going to want to change a little bit is the evaluation. If you're getting a good, smooth result here, then I wouldn't worry about it so much. But if you're finding it's a little bit choppy, which sometimes it happens, what I would do is I would reduce this down slightly. So basically it's going to calculate twice per frame, so that it'll look at the halfway point, and it'll just give you a bit more of a fluid evaluation. So I'm going to go in and I'm going to create that now. Oh, there's no name, so let me call it rocket trail. Rocket trail. All right, and let's create that. What's going on here? Oh, because I didn't have it selected, of course. So one more time. So end cache, and so rocket trail and create. So let me just put this down here. And to be honest, so it's cached, but I'm not getting as nice of a result, and I think it's because of those subframes that we added. So you know what? In this case, I'm going to actually go in and I'm going to replace that. So I can always override that file. So I'm just going to redo it with just calculate every frame, and I'm going to create that. I'm going to replace it, and just you can do replace existing. That's fine, because I think this is actually a slightly better result. Cool. And once that's done, now it's kind of locked in. It bakes each frame, so I can now go in and tweak this. If you need to change your animation, you'll want to replace the cache again, right? You'll have to recalculate the cache. Or even delete the cache and maybe test it a few more times if it needs to, just so you can see it working with your new animation. To do that, you'd have to go under the end cache and then delete the cache from there. So that is something that you would have to think about. All right, so I'm going to end part 1 here, because I do have to restart my machine, just so that I can get my Redshift working, so I can show you how to hook up those shaders. So I'm going to go in and do a save, and I'm just going to end part 1 right now.